The next method we are going to explore for cost estimate is assemblies estimate or system estimate. Let we walk through the overview picture of estimate, the graph that we have shown in the last few lessons. So far, we already deal with the order of magnitude estimate that we use two methods, index-based and cost capacity factors. And then we walk through the square foot cost estimate. And now move on to a more detailed estimate, and we call it assemblies or system estimate. So this is the gap, bridging the gap between the square foot and unit cost. In the square foot, we only know a basic parameter of a facility. For example, how many square foot, how many cubic foot, how many cubic feet of the warehouses, etc. Now go to assembly, we go more into detail, different assemblies or different system. For example, what is the roof look like? What is the air conditioning system look like? What is the structure look like? What is the processing unit look like? What is the treatment system look like? So all of that is a little bit more detail, but the engineering detail on the design detail will not be sufficient to the level that we can use the unit cost, which will be discussed next week. So now focus on assembly estimate. Before we move on to the next slide, I just want to capture a few note here about the assembly estimate before we continue. So it's basically a budgetary tool in design development stage, so that we can see, oh, for example, you build a house, you want a clay tile, something we did in problem 2 of today's lessons. And then as you can see in that problem, clay tile is more expensive than asphalt shingles. So when you see that, if your budget is not sufficient to use clay tile, we can remove that system, the clay tile, replaced with asphalt shingle. So that basically easy, good budgetary tool in design development stage, that we can change the system to meet the requirement, the constraint of the budget. And we group of items at a convenient unit of measure, like structural system, processing system, MEP system, mechanical, electrical, plumbing system, or roofing system. So those are the convenient unit of measure. And we organize, follow the ASTM Uniform 2 classification. I will show you that in a minute. And then if you need any further, we can go to the assembly estimate slide, and which I walk through in here. So what is the ASTM EI E1 1557 Uniform 2? Basically classified facility into division, and they make it from division A to division H, as you can see here. Division A for substructure, something below the ground, foundation, etc. Civil work, plumbing, that substructure. We have shell like gore, steel structure, interior construction, interior gore, etc. Services, air conditioning, equipment furnishings, special construction and demolitions, site work, pavement, parking, and general conditions, some indirect work required to complete the project. So that's the way they organize for assemblies or system estimate. In the next method we learn next week, we learn a unit cost estimate, the way they organize a little bit different, and we will talk about that later on. But for now, uniform 2. Let's look at one or two division A and B, and look more detail what is that about in those division. So as you can see, division A and division B, division A substructure, we have foundation, and it also have level 2 foundation, and that is A10. So when people use that ASTM stands for American standard for testing and materials. And that A10, it means foundation. And in foundation, we have another level, which is level 3. It's standard foundation, special foundation, standard foundation, something like spread footing, etc. Special foundation, deep foundation, slab on grade, basically the concrete slab on the ground, that is slab on grade. And then basement construction, it's not in Florida, but in other part of our country, we have basement construction. So all of here is substructure. So if you want to estimate about the foundation, then it go to division A. So everyone in the industry will have the same language to communicate. Similarly, for the shell, we have a substructure, a superstructure. So floor construction, roof construction, exterior enclosure. So you have exterior walls, exterior windows, exterior doors, and then roofing, covering, openings. So that you can see all up here, consider a system. For example, here for shell, we have B30 can be a system, and that we are apply one single system in problem 3 of today's lesson. And then, of course, with that same knowledge, you can apply to estimate for any other system. Add them up, we can have the total costs using assembly estimate for a facility. So this is detail of all other division. If you are interested, I have that in the reference in on Canvas with that ASTM standard 1557, and we have all of that classification for 3 level of that system. And then how people link, for example, here one project to with different classification to different item that apply for that project. So you see cost estimate summary. So let's go down here. You have that here. So yes, either classification for different components or different system based on the uniformat tool. And for example, here, if you have exterior wall, we get linked to exterior enclosure, and we have all the item, have the quantity, the unit, then we can determine the cost. So that is basically pull out each system and fit into. So one advantage of this method is we can be able to replace one system to another. Something I told you, like if clay tile for the roof is too expensive, then you can be able to replace with the asphalt shingle without making significant change to other design components. So that back to the slide here that we cover. And for industry, they have annually publications for the assembly costs. And in this case, the IS means we use a lot in the last 2 lessons, and that another book published every year. This is 2020, that is assembly cost. So let me break down one example here. One example, for example, roofing, roof covering. So one system in there, in this case, green roof. So it have, you see the green on top here, vegetations on the roof, structural roof support, etc. So all here consider a system, and that you can see everyone prefer green roof. And of course, have to be trade-off between the cost and the environmental impact, things like that. Some people are concerned about the cost, and it may or perceive or should be the cost for the green roof a little bit more expensive than the regular roof, so people hesitate to invest on, despite may have a long-term positive impact to the operation and maintenance costs, and it also the environmental issues. But you know, depends on perspective. But for the cost, we can see the idea of if a green roof in this state, whether it's expensive, can we replace with the green roof or the traditional roofing system. So this kind of estimate easy for everyone to develop and give an idea during the development state of the design to see which one is, with time of system, with time of design will meet the budget from the developer, from the owner point of view. And here, go to further, as you can see, break down to the cost for each system. So it's very convenient. And continue further for each system. For example, the roofing, we can get the money, and other services, we do the same. At the end, add them up, like I say, and we can get the cost for the total cost for the project, consider on other division, consider on other overhead, profit, etc., so that we can uh, get the cost. So for this purpose of this class, we don't go to on the division. I just pick out one in the shell and the roofing, and we will do that in uh, problem problem 3 for the roofing. So one system, but with that same concept, you can apply to other system as I mentioned earlier. So that, and this one you see apply for residential or commercial or institutional um, construction projects. It can also be applied to industrial projects. Just give you an example here, a case that we talk a lot about the Duke ITCC, Duke Energy, and everyone may know the company just like FPL, but they also have other states, including northern part of Florida. So they built a power plant in Edwardsport, Indiana. So the similar plant is in Polk County, Florida here, built and completed in 1994, and now they plan at that time 2007 for this project. And as you can see, that relate to our lesson 3, that use the historical data, the reference project, and bring it to the new project that built 13 15 years later, and that in this case. And in this case, the combine between the method we learned in lesson 3 and also different system that you have here for the assembly estimate in this class. So you make the quantity for each system. So group, heat exchanger, tank, equipment, packaging unit, gas turbine, generator, all of that have at a system with the reference project in the past. Because at this stage, 2007, this project just about to start designing, no detailed design. So you have to rely on the historical data. In this case, historical data is a power plant built in 1994 in Florida. And then with that, they come up with the estimate, indicative estimates, so basically very early stage for this industrial project. And you see that gasification Iceland, we have all at a system. For example, gray water. What is gray water? For those of you environmental engineering major, you know that need a treatment, etc. So CO2 recycle. So all of that are the system required for a power plant. And then we have power island, so the unit that generate the power. We have a turbine generator, all of that. So add a system, they have a indicate the money, and then direct costs, indirect, all of other specific, that the total is about 1 billion at that time. Believe it or not, 1 billion at the end of this project, if it completed 3.5 billion. So you see that basically 250% increase in the cost over budget for this project. That's why this project create many problems. If you go back to the lesson 1 on Canvas, I put you a link about what is technology they use for this power plant. And as you can see, relate to lesson 3 we learned is in this case the output or capacity is a megawatt. So this one about to produce 600, about 630 megawatt, something in wastewater treatment or water treatment. We're talking about a million gallon per day, etc. So that's the way that they apply. And sometimes we use multiple methods to come up with the estimate, depends on the information we have at that point.